Hello, good evening. I'm trying to find the very right angle, good angle for this because we have very limited space, and then I don't want that lighting reflected on this whiteboard because it will give you this glare that's really bothering in the eyes. So anyway, so yeah, yesterday we talked about. I think we finished it off with this important important point of using the equity cushion in human relationship. If somebody, so first you have to build up this rapport, like good relationship. You have to get this person like you, right? And if this person really like you, then this person will be more forgiving of you. Okay, then that's the point when you start exercising this person, correcting the bad habits. Okay, so that's how you can save somebody, save a soul as a humanological ghostbuster. Okay, or humanological exorcist. Okay, uh, yeah. So that's salvation of people. Just people around you, your loved ones, friends and families, or it could be a random stranger, whoever it may be. Making a better world, making people better people, to save people's souls. It's very Christian kind of biblical, Jesusian, New Testament way of worldview, and humanology adopts that. Okay, and uh, we just found a way to do it, right? Like in the last episode. Okay, so let's continue on the discussion. We'll cover the preliminary right now, okay? Because we're gonna. It has some application. It's a mathematical, computer science kind of programming kind of concepts. You like it, okay? You like computers, don't you? Even if you don't do computer programming, but still it'll be exciting, okay? So later, what we're gonna talk about is this power of a group, okay? Power of ism, a group about you, group about a person. That's what we're gonna talk about because if you become a famous person, you become a celebrity, then you become a concept. It's kind of like you evolve to be a concept. You become a household name. Okay, like this scientist called Feigenbaum. We'll talk a little about chaos theory in physics back in I think it was like 70s, 60s, 70s, 80s. Chaos theory. There's this book called Chaos Theory. I think it was written by I think he was a New York Times journalist. Probably the book came out in 90s, I think. But it was a very well written book, and it was a very hugely popular book at that time. Chaos Theory. So it was basically this New York Times journalist, interviewing many uh, contemporary physicists, scientists. So what's going on in science of chaos theory? It was kind of brand new theory back in those days in 1970s, 80s. So yeah, he chronicled kind of development of this chaos theory. Talked about many scientists in chaos theory, mathematicians, and one of them was Feigenbaum. I think he now is a physics professor in Rockefeller University in Manhattan. Uh, I've never met him, but yeah, great physicist. Okay, he went to MIT, physics, and he worked for some national laboratory, in New Mexico, I think. That used to be the mother bed of this Manhattan project. Okay, so I'm Feigenbaum is contemporary fairly. Okay, he was not part of that Manhattan Project. Well, he's not that old. I'm saying there's this laboratory. I forgot the name. National Laboratory, research institution in physics, right? So Mr. Feigenbaum, Professor Feigenbaum, Dr. Feigenbaum, he worked there, okay, in that laboratory. They used to do all those Manhattan projects, nuclear bomb and stuff, okay. And then later he became professor in Rockefeller University. Okay, so and they talk about Feigenbaumology. Okay, so if you are famous, then you become a concept. Okay, so or Einsteinism or Einstein science, science of Einstein. Okay, Einstein is very famous person become a concept, a household name, right? But even if you are not very famous, you still have a group. You know, let's you've seen me in this suit and tie, so I'm gonna put on my jacket, okay? Maybe because it is cold, man. It is. We had this frost on car windshield today. Today is what, September, near the end of September, and we are having a frost already. And so first time in the, I mean, this year, I mean, after the summer, I had to scrape off those frost off of my windshield in the morning. Okay, so so basically, what we get back to it, the application thereof. Okay, so it's about person group. Okay, just one more thing before we jump into the preliminary stuff. You're a person, right? There are people who know you. Okay, like that's your group, and there's anti-group, people who just hate you. Your pro group of you. Your, let's say your name is what, John Doe. So pro John Doe East, your families and friends, and anti John Doe East, your enemies. Okay, your competitors. It's dynamic set. Okay, people immigrate back and forth. Then some people they just forget about you, so they become your acquaintance and or whatever. So the neutral group. Okay. Now, preliminary stuff. Let's talk about computer science and mathematics a little bit. Okay, computer science, like computer programming. Yeah, I used to be a programmer. I still can program. Okay, who knows? I may go back to that, but yeah, no one can tell. Yeah, I like computer programming. I love it. Okay, no, don't get me wrong. It's just that as a job, I've doing for 2 decades. So that's why I switched over to another profession. But I love computer programming. So computer programming, yeah, we are the birth of computer science is actually mathematics. Okay, there was no such a thing as computer science before, but later on, smart people like Paul Neumann and there's a lot of mathematicians who started showing interest in computers. Okay, this machine, brand new invention. Okay, Alan Turing was one of them, but I don't give credit to Alan Turing because probably because he's gay. Okay, I don't like, because I think Alan Turing is probably exaggerated. His achievement is exaggerated. He's overrated just because he's gay. Okay, I hate that stuff. Okay, so gay people tend to be acclaimed more because it's like kind of affirmative action. You know, black people, they get more scores when they go to college, right? They get preferred treatment, and gay people same way. Alan Turing, just because he's gay, he tend to be more appreciated than other computer scientists, and that disgusts the hell out of me. Okay, because that's so unprofessional attitude. Alan Turing, all he did was, there's a mathematician called Gödel. I think he is European, and then he came to America. I think fleeing from Nazis, fleeing from Hitler. Not sure if he was a Jewish or not, but just like Einstein, he fled from Europe because they didn't want to be a part of all this Nazism and madness. So Einstein came to America. He fled from Nazism back in the days. So and then he became professor in Princeton University, and I think Gödel, he probably similar case. Okay, so not just Jewish scientists. There's some other scientists who fled Europe. Okay, not sure if Gödel was Jewish or not, but he's from Germany. So a brilliant mathematician. He had this Gödel's incompleteness theorem. Okay, so and Alan Turing's like halting problem, all that shit, is from that. Okay, Gödel's incompleteness theorem is just application of that, and also there's this Church, a British mathematician called Church, and also British mathematician called Hoare. Okay, I don't know how to spell it. Something like Hoare or something. Yeah, a lot of mathematicians, okay, and logicians, and that's the basic development of computer science. Okay, so Alan Turing, he didn't really come up with something new. Okay, so yeah, he's credited with this cracking the code, Nazi German secret code, something like that, right? Yeah, maybe it has some contribution to the ending of the World War II, but I don't think it was that essential. Okay, I think probably the alliance defeated Germany no matter what anyway, because Germany became pretty much alone later in the World War II. So I don't think Alan Turing's this cracking the code or his halting problem, his this Turing machine in computer science, I don't think it has that much significance. Okay, he's overrated just because he was gay. All right, so that really disgusts me. So I don't like Alan Turing. Okay, and yeah, to me that's all a bunch of garbages. Okay, all this Turing machine theory, all garbages, all garbage. Okay, so yeah, I would just discount everything that he have ever done, right? Because yeah, because he's overrated just because he subscribed to gayism. That disgusts the hell out of me, right? Anyway, okay, so we're not gonna talk about any of his bullshit theories about in computer science and mathematics because he doesn't have any contribution. Okay, yeah, I deny Alan Turing. I don't like him, right? So anyway, so we're not gonna talk about any single one of his stupid theories, all right? So in computer science and in mathematics, all right, there's some similarities because computer science, well, it's kind of interesting story. It's a kind of convergence. So there is Einstein and there is Thomas Edison, right? When actually Einstein was kind of overrated too. He doesn't have much contribution in a practical way. His theories of relativity actually it doesn't make money. It costs money. To prove that his theory was correct, you need these fancy equipment and everything. Okay. He didn't quite contribute too much in science, in physics and engineering. All his theories are just too theoretical. Okay, and it may be true or it may be false or it may be incomplete. It may be a better approximation than Newtonian physics. Okay, so it may not be the final destination of the finality of physics development. All right. because Newtonian physics is already very good approximation to the reality. Okay, so we don't need Einsteinian theories in a practical way. E equal mc squared. Yeah, well, it's not that significant. It's not such an important equation in engineering or physics. Yeah, there's this nuclear bomb or nuclear reactor. Okay, so is nuclear bomb that important in human history? I don't think so because we better not use it, right? Nuclear power, yeah, it's very dirty source of energy because you have this nuclear waste. What are you gonna do with it? Not in my backyard, NIMBY, right? Yeah, so nuclear energy is not that popular. It's not that huge contribution to human energy consumption. Okay, even in nuclear physics or nuclear engineering, E equal mc squared. Yeah, you can use it. There's some just loss of mass and it becomes huge energy. Okay, but it's not that important. It doesn't play that much of a role. Okay, so again, Einstein was not a part of Manhattan Project at all because they didn't need him. They did not need his relativity theory to develop nuclear bomb, to develop nuclear power. No, relativity theory doesn't have that much relevance or significance or application in those practical matters. Okay, his theory is just theoretical. So Einstein is a very very overrated scientist. All right, and um, probably just because he's Jew, right? Because yeah, Jews tend to be overrated. Are Jews smarter than other people? I don't think so. I have many Jewish friends, okay, or many Jewish acquaintances, and I don't think they are smarter than other Americans. To be honest, they're just like any other Americans, okay. Maybe they used to be smarter, but nowadays I don't think they're smarter than other Americans, okay. Or other Europeans. I've seen some Jews, some people who call themselves Jews, who are more stupid than average Americans. Okay, for not as smart as average Americans, less than Americans. I've seen them. All right, probably half of the Jews I've seen they are sub like below average. The other half above average. So it's just like bell curve. Okay, I don't think there's anything special about Jews. Not anymore. Maybe they used to be smarter, but not anymore. Because I see Jews all the time. Many of them are my friends, acquaintances. I told you I have no enemies. But some Jews, yeah, well, they don't like me. And they're not my favorite people. But they're not I have no enemies, okay? If you're a humanologist, you have no enemies. You are more like Jesus, yeah, okay? And humanology is not Christianity, okay? They're totally different. But humanology accepts core, many of the good things from the Bible, and also from maybe from Christianity. So there's some intersection, okay, between Christianity and humanology, but we are not the same, right? I don't go to churches, not anymore, because I have more things to teach than learn. If I go to church, it's so boring because I've been to many different churches. Okay, they tell me all the things that I already know, or they tell me something that I know to be false. Okay, so I don't go to churches anymore. I don't want to. I won't ever. All right, but they're like more like my parental figure because I learned so many from them. I grew up in churches. Yeah. Anyway, so computer science and mathematics, we have a lot of similarities, but they're not the same. So, for example, you have mathematics and then computer science, okay? You cannot quite see this, can you? Doesn't matter. It's not very important. Okay, so, and then there's this, you don't need this table. I don't want to write down one thing twice. I'm lazy. X is equal to 1, right? Can you see this? My goodness, you cannot see this at all. So I don't want to keep using blue, alright? I'm fed up with this color. Let's use red. X is equal to 1. Much better, right? In mathematics, this is an equation, right? Like x squared plus x plus 1 equals to 1. So this is second order equation, this first order equation, right? It's too easy? Okay. 2x equal 1, right? What is x? 0.5, right? Yeah, that's how it looks like in mathematics, arithmetic, right? But in computer programming world, we never, if you write like programming language, like if you are coder, we never do this. Almost never do this. We always do this. X equal 3 or x equal 5. Okay, so here this is what unknown. In mathematics, you have fx equal like 2x, right? And this is function, right? So x is in the y equal fx, right? So x is the independent variable, y is a function of x, y is a dependent variable, right? So those are the mathematics, okay? So in computer science, this is not an equation. So in computer science, like computer programming world, we adopt this symbol of equals. This is equality in mathematics. In computer science, this is not an equality sign. It's an action of assignment. X, we call it variable, but it's not exactly a variable. It's a data storage. It's like address of this in this RAM, randomly accessible memory or in a hard drive, right? So it's a memory location, and we could just call it a name. We give it a name like X, and we assign this address, this space in the memory in computer. We assign the number 3 or data, okay? And then why? Because we declare this variable as an integer X, okay? If you're using Java, you put this. If you use the semicolon, it's like a period. So every line is like a sentence. So computer programming language, right? You have Java language, you have Visual Basic, you have C Sharp. So C Sharp and Visual Basic, they're probably two most popular language nowadays in computer programming world. But I learned Java, okay, as a C Sharp is based on Java, okay, and Visual Basic is based on Basic, and maybe a little bit of COBOL. So I majored in computer science, when I was doing undergrad, so I know all about it, okay. And so yeah, you declare your variable as an integer, but if you declare your variable as string y, right? Semicolon as like a dot, period of a sentence, okay? X, you assign X as 3, and then Y is a string, you assign as A, B, C, okay? Something like that, okay? So why am I doing this? Because we need to learn the concept of recursive function, okay? And just like here you have variable, which is just it's not the same as mathematical variable. We just adopt the language. In computer science, we adopted a lot of languages in mathematics, but they are not the same. All right? They're similar. There's some similarity. So we have equality. We adopted this symbol of equality, but it's not equality. It's assignment. Okay, in computer science, and we have this computer science, this programming variable, but it's not exactly same as the variable in mathematical sense. Okay, they are shorthand nickname for memory or the address. Okay, because x and y, they're different location in the memory, random access memory, or in the hard disk memory. Okay, you have a lot of memory, right? You store different data in different location, right? And each memory, like byte or bit, it has address. Okay, either 32-bit or 64-bit memory. Okay, so that's and yeah. Okay, so that's we may talk about this more sometime later, like computer science, mathematics, and stuff. Okay, this is interesting. Okay, it's good to know. Good brain exercise, intellectual entertainment, and so you have equality symbol and variable and function. In computer science, function also is not exactly same as mathematical function. So let's say function fx, and x is integer, right? Is equal to return 2x. Okay, so it's kind of similar to mathematical function, okay, but return, all right? So if x is 1, you return 2 times 1, which is equal to 2. If x is 5, 2 times 5 equals 10. Okay, so there's input and there's output. You plug in 5 and it spits out 10. 2 times 5 equals 10, okay? So input, there's input and output, okay? So let's say you have this web page. By the way, if you have this kind of like PC or some laptop, I don't know about that Macintosh, because I don't own Macintosh, okay? But if you have PC based, you can actually write a computer program without purchasing anything, any software, special like compiler and stuff. You can program, okay? It's called programming language called JavaScript. It's based on Java, but it's a JavaScript is a computer programming language that is has to do with web page. Okay, so I tell you briefly how you can start programming in your computer without purchasing or downloading anything. You have PC, you can program and you can test it. So you have Notepad, right? Your Notepad, that comes with the Microsoft operating system, right? Notepad, open a Notepad and create a file, call it, and save it as all files, okay? So, and you name it as a.htm, okay? Or xyz.htm, so it's a web page. Then you have, in that a.htm file, you have this script, then script, and you put some blank lines here between this, okay? And then you write JavaScript, okay? So it's been a while. I think it's like document.write, document write hi, okay? So, and then you save this, and then you close it, and then you double click on that a.htm that you could just created that have this text in there, okay? And then what's gonna say is it will open a web browser, like Edge or Microsoft Explorer or whatever your default web page is, or Firefox, Google Chrome. You will open a web page, okay, and you will say in that web page, high. Okay, in computer programming, they tend have their tradition is a hello world. Okay, that's your first, very first program in any programming language. It's very useful thing to do because when you if you are doing computer programming in a brand new language, yeah, that's the very first thing that you do. You want to make sure if you write a language, you just print out some letters and make sure it works because in computer programming you may have some interpreting language like interpreter or some compiled language and that uses compiler. Okay, so there's many things that goes on in computer programming. Okay, you want to make sure everything's working, like being compiled or interpreted, and then it displays properly in your computer. So this is very first thing in any programming language that you do. Okay, and so yeah, then you can program for fun. Okay, it's computer programming language is very fun to learn. Okay, so but don't be a hacker. Okay, be a good person. Okay, don't. Okay, what hacker does is they steal. They're like robbers, digital robbers, cyber robbers, and thieves. Okay, it's bad. Don't do that. Don't be a criminal ever. That's the dark side of the world. You're basically shaking hands with the devil. Okay, that's what you should never do that because devil will not thank you for that. He will kill you. Okay, devil is pure evil. You deal with the devil, he will kill you in the end. Okay, he's not gonna thank you. Yeah, so don't do that. So yeah, we covered this equality symbol, variable, and function, right? In computer science and mathematics, that's similar. There's some similarity, but they're different. Okay. Then let's take a break. I need to ventilate this air. It's carbon dioxide buildup. Let's take a break. Oh, getting stuffy in here. And overheated. Hi, I'm back. I apologize if I kind of look hyper today, talking very fast. Um, well, we got a lot to cover, so I kind of feel high energy today. Politically wise, we're not gonna go there today. We have too much to cover. Okay, so yeah, high energy. Okay, a little bit high energy today. So we are not gonna go into politics because today is not the day. We have too much mathematics and computer science to cover today. And I'm doing this for free because, well, I'm not interested in money. I don't need more money. I'm making enough money to pay my bills and purchase vodka and cigarettes. Okay, so um, and also I learn many things for free from YouTube. So I'm giving something back, okay, to the world. Wikipedia is all free, right? I did donate uh, Wikipedia once, I think, uh, to let them publish a Wikipedia article about my movie, but they rejected it. But that's fine because it's Wikipedia policy. They are not advertisement site, so my movie is not famous yet. Later on, maybe somebody will make it for me, or maybe I make it. I don't know. If my movie become famous later on, okay. But now it's not famous, so it's not like a not more like an advertisement venue. So they rejected it, and I'm okay with that. Okay, so but some people sympathize with that. Anyway, so mathematics. We need to cover mathematics. There's what's called sequence. Okay, it's something like you see in the IQ test. Okay, one. Uh, 3, 5. In this sequence, what will be here? Too easy, right? 7. Mathematically, we call it this. AN is equal to A. Oh, AN plus 1 is equal to AN plus 2. And A1 is equal to 1. This is a mathematical sequence, alright? You've probably learned this in calculus class. I don't know. As a computer science major, I had to take 3 calculus classes. Calculus 1, 2, 3. Calculus 1 and 2, that's something I learned in high school in Korea, South Korea. So I just took the exam and I passed it. So I didn't have to take calculus 1 and 2. Calculus 3, yeah, I took in America, in a undergrad university in somewhere in Midwest. I'm not gonna tell you where. Okay. So we talks about vector calculus and like Stokes theorem and Green theorem and some new stuff. Okay, I didn't learn in Korean high school. Okay, so I had to take that. Great classes. Okay, so but in terms of education, mathematics was mostly developed in Europe. Okay, mostly continental Europe and also England. Okay, that's mathematics. And before that, yeah, of course, the foundation in Greece and Middle East, like algebra, and geometry is more Greek tradition, algebra more Arabic tradition, Arabic number system. That's what this is. 1, 2, 3, 4, 5 is from Arabic, okay. And also zero from India, South Asia, India, okay. So, but in terms of mathematical education, I think probably Asia, Far East Asia, like China, Korea, Japan, especially Japan. Yeah, they did fantastic this mathematical education system. Okay, and they came up with wonderful symbols too. Okay, so like like combination and permutation, right? NC3, NCR. In Western world, you do this. We cover this when we did the Pascal's triangle. Binomial coefficient, right? But in Asia, I think this symbol may have been invented by Japanese. I'm not sure. So and then because Western civilization, Eastern civilization came from China and then Korea and then Japan. That's the Eastern civilization. First started from China, then it propagated to Korea because peninsula. Then it went over to Japan. But Western civilization, its introduction came from Japan, then Korea, then China. Okay, yeah. So mathematics is a Western thing. So Japanese learned it first, and then they passed it to Korea, then China, something like that, or Korea and China at the same time. Because when during the Japanese colonization era, or some foreign exchange students, scholars, stuff like that. Okay, so um, and NPR, it's not National Public Radio. Well, I used to like that radio station, but now I don't. Okay, they're too liberal. Okay, they talk about gay marriage and marijuana and tattoo piercing, all that crap. Ugh, disgusting. So yeah, NPR is this permutation. Okay, so this is equal to well, this one first. NPR. Okay, first of all, n factorial means n times n minus 1 times blah 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 times 1. Okay, so 3 factorial is 3 times 2 times 1 equals 6. Okay, goes like that. NPR is like n times n minus 1 times we do this r times. Okay, and this is equal to so 3p2 is equal to 3 times 2, we do it 2 times. Okay, times 1, so this is n factorial over r factorial. Okay, so we disregard 1 plus n minus 4 factorial. Okay, so this is 3 factorial. Here we have 3 factorial over 1 factorial. 3 minus 2. Sorry, 5p2 is equal to 5 times 4 is equal to 5 factorial over 3 factorial. Yeah. Okay. And this is this. NPR over something like r factorial. Okay, so let's see this. Okay, and so 5c2 is equal to, okay, 5c2 times 5c2 is a combination. Okay, there are 5 balls, A B C D E, A B C D E. Okay, A through E, A B C D, and you there are balls, 5 balls named A through E in a bag, and you pick 2 of them as a combination. So ordering does not matter. How many ways to pick that? That's what this stands for, okay? Disregarding ordering. But if you do care about ordering, then you multiply by 2. And this becomes 2 factorial, okay? Then this becomes 5p2. So yeah, it's that, okay? And this is becomes n factorial over r factorial n minus r factorial, okay? So yeah, this is correct. Now, so this npr also, yeah, I think it's Japanese notation convention, okay? And then there is this pi, like n pi r and nhr, and this is this is called permutation. Okay, permutation that allows repetition, and this is h is a combination that repeats that allows repetition. Like, okay, from through A to E, you can pick multiple A's. Okay, 2 A's. Okay, and if ordering matters, then you use this pi. Otherwise, ordering does not matter. Orderless combination that you allowing repetition, you use this. Okay, and there are this respective formula for that. Here you have just n to the r. Okay, so that's that. H, I totally forgot. I think it's something. I thought it's something like the n plus r plus 1 c r, something like that, or n plus r minus 1, something like that. Okay, so I used to know all about this, but forgot. Anyway, okay, so sequence is that, and in mathematics this sequence, and we need to talk about series. All right, mathematical series. It's nothing but summation of all the sequenced numbers. Okay, we talked about limit, mathematical limit. It comes up from all this. Okay. Yeah, that's why you learn about sequence and series in calculus class, because in order to understand what calculus is and limit, that's a very essential concept, fundamental concept to understand derived calculus, derivation, integration and all. Okay, so and then there's what's called a Fibonacci sequence. Fibonacci, you know, Italian. There are a lot of Italian mathematicians back in the days. 1, 1. You add this previous 2, 2. Okay. Then you add previous 2 to get the next one. 3, 2 and 3, 5, 5 and 3, that's like 8. So yeah, it turned out to be some kind of exponential growth. Okay, Fibonacci number. Yeah, that's mathematical expression of this function of Fibonacci. Even generalized Fibonacci function fx equal blah blah blah. It turned out to be kind of exponential. Okay, I mean in the degree. You have in computer science the big or small or notation. Yeah, it's kind of similar to the order of magnitude, you know, the exponential function. Okay, and So, mathematically, what would be this? How would you express this function? 1, 3, 5. Take a y equal x2, I think. Right? You put 1. Okay. 1. 1, 3, 5. Is it x equals 0? No, no, no. It's x equals 2x. Y equals 2x. Minus 1. X is equal 1, then you become 1. X is equal 2, then equals 3. X equals 3, then 5. Yeah, yeah. Okay. It gives you this sequence, alright? Some variation of this, but 2 will stay the same. Okay. Yeah, it's this. So this is the slope, alright? So it's like differential. So this is equivalent to, or equivalent to an plus 1 minus a1 is an equal to 2. You see the differential. If you remember the slope concept, right? And like dy dx, you know. So yeah, difference is 2. You remember that, like we have this first degree, you have displacement and velocity, and then acceleration, then second degree acceleration, third degree acceleration, blah blah, right? It's about difference, okay? So it's constant, it's a constant velocity, okay? It goes like this, y equal to x, straight line, alright? So yeah, this kind of sequence is that, and then let's talk about series. I told you there are a lot to cover, right? If I'm going too fast, just you catch up by googling, Bing, Wikipediaing, okay? Because it's not too important. If you don't understand any of this, don't worry, because it's not that important. Humanology, well, I'm not your mathematics teacher, okay? I don't do a very good job in it because that's not my profession. So I don't have requisite skill or patience. Okay, so I'm just giving you some key terms that you should look for, search for in the online to catch up. All right, that's what I can offer you. All right, so series is like this. Series. So you have sequence. You have sequence. 1, 2, 3, blah blah blah. The sequence. Series is 1 plus 2 plus, you just add them up, right? And the formula for plus n, formula for that is 1 plus n over 2. Okay. It's because you have series 1 plus blah 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 plus n. It's really the same as series n plus blah 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 plus n plus 1. You add these two rows, okay? Then 2 times series is equal to 1 plus n times 2, because they're the same, because plus operation is commutative, so ordering doesn't matter, right? It doesn't look right. Is it like, I think it sounds like this. Yeah, it's this. How do you derive that? I want to derive this, okay? I want to derive this formula. Why is this n plus, man, I used to know that stuff, man. If you are learning mathematics in undergrad school, you may be laughing at it. It's been such a long time. Oh my goodness. Let's reverse engineer, okay? So 2Sn, that n times n plus 1. Okay. Oh, I kind of see it. Kind of see it. So S n is equal to n plus 2 n minus 1 plus 1. If you add them up, with n plus 1 plus here n plus 1 n plus 1 is equal to n times n plus 1. That's why Sn is equal to n plus 1 over 2. Okay? You are adding this two up. Okay? So, yeah. Okay. It's easier than I thought. Okay, so series is this, you have a sequence of numbers, then you add them up, that becomes a series, okay? And so yeah, those are some preliminary stuff, okay? Please bear with me if I'm boring you, but at least it's something exotic, right? You don't get to see this in your daily life because this is a mathematical language, okay? Again, it's intellectual entertainment. We talk about politics, we talk about religion, we don't really write in mathematical language, but that's what we do in humanology. We use mathematical language to explain phenomena in politics and religion. That's why I'm trying to familiarize you with mathematics. I'm introducing you my friend mathematics, okay? So but we don't have too much time because I have limited energy and time, so I do this after I come home from work and before my dinner, okay? So as time goes by, I get hungry. So we have limited time, all right? So yeah, but I'm giving you some idea what to look for, search for in the online to catch up. But you need to catch up if you want to become a humanologist, all right? You need to know mathematics, okay? Because that's what humanology is about. It's science plus religion. We are expressing religious concept in a mathematical, scientific language. All right. So yeah, you need to know both. You have to if you want to become a humanologist. All right. And so let's move on. Okay, recursive function. Recursion isn't really a mathematical term. It's recursive function. That's more like computer science term. Okay. So you had this function, right? We talked about factorial function. Okay, like factorial n go to n times n minus 1 times blah 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 times 1. Okay, so 3 factorial is 3 times 2 times 1 equals 6. Okay, if you want to program this in computer science, computer programming language, is this f x well, x is integer, so this local variable. Okay, so let's say int x, okay, is equal to if x is equal to 1, then return 1 semicolon. It's like comma. If x is more than 1, return f x minus 1 semicolon. Okay, so that's a function. Yeah, you can say if else and if x is equal whatever. I'm skipping all the details. Okay, let's assume that you put some natural number. Okay, all right. So if you less 1 or less than 1, then you return 0. If it's x is more than, then return x minus 1. So what goes on here in this, we call it recursive function. So it's a recursion. Okay, what it means is recur, it's happening again, because look at this. Inside of this function is calling itself with some different value. All right, so let's see what happens when you put f2 is equal to f, what is 2? 2 is more than 1, right? So you return f times 2 minus 1 equals f1, which is equal to, so you're calling the function again 1. What is 1? f1 1. Okay, let's see what, oh sorry, x times f x minus 1. So 2 times x. Okay, sorry, as an apology I do it again. Okay, f3 is equal to, 3 is more than 1, right? So you have 3 times f x minus 1, f 3 minus 1 is equal to, is equal to 3 times, what is f2? 2 times f1, which is equal to f 3 times 2 times 1 equals 6. Now, yeah, so that's recursion. Okay, recursive functions. Why am I doing this? I didn't have to. I'm just giving you this concept of recursion. Okay, so that's the recursive function in computer science, computer programming. Okay, and it's very related to mathematical recursion or in chaos theory, because chaos theory, they call it like fractal, geometry. It involves first some recursive function in complex number. Okay, it has to do with complex number. That's what I read in that book, chaos theory. And there was this mathematician. The name escapes me, but yeah, he was. I think he was in Hungary or some Europe, and he came to America. Escaping from Bourbaki movement, which is very formalistic mathematical movement in Europe. Not sure what country, probably Hungary or something. Then he became a professor in Harvard University in mathematics, and Mandelbrot. Yeah, Professor Mandelbrot. Okay, so yeah, he is a pioneer in this fractal geometry. It's very beautiful. Probably one of the most beautiful mathematical geometry, this computer generated image. Okay, so yeah, like it's not something new. He just kind of expanded what existed before, based on what existed before. Like Julia said, there's this Koch, the Koch, Coch in Germany is pronounced as a Koch, whatever. Okay, there's this famous Koch snowflake. Okay, Koch triangle. It's like you have triangle, right? But it's recursive. So each edge of this Koch triangle have another triangle. Okay. So it existed before Professor Mandelbrot in Harvard University. Okay. Yeah, it is very well known. Then each of edge of this triangle have another triangle. So that's the concept of recursion in mathematics. Okay. And it goes on and on. Okay. Ad nauseum. It repeats itself. Okay. It's like this. So this is pure mathematics, and by the magic and power of humanology, we're gonna apply this in politics. Okay. You have a country, okay, and then you have a state. Let's say you have two states. You have country, and you have two states, S1 and S2. Each state have two cities. Let's say nation. You have one nation under God. Okay, then one nation have two states, and each state have two cities. No, two counties. We call it C1, C1, 2. Counties. State 2 has a county, also two counties. 2, 2. Each county have, let's say, a town. Now, you have town, 1, 1, 1. Each county have two towns. Town, 1, 1, 2. Town, 1, 2, 1. Town, 1, 2, 2. Town of these two towns in this county, 2, 1, 1. Town, 2, 1, 2. Town, this belong to this county, 2, 2, 1. Town, 2, 2, 2. All right, so this is the mathematical concept of recursion. Okay, because in mathematics you have number, scalar, right? Like 7, right? There's a zeroth dimension, and then you have a vector. fourth dimensional vector. 7 comma 2 comma 3, right? And you have second dimension, which is planar. So fourth dimension, zeroth dimension is like a dot. Fourth dimension is like a line. Second dimension is like a plane. We call it matrix. Okay, 2 comma 3 comma 1, 5 comma 2 comma 1, 0 comma 0 comma 3. Okay, it's called a two-dimensional matrix. And we can have three-dimensional matrix too. We can have n-dimensional matrix. Okay. So and in mathematics we typically stop right here. Okay, because more than two-dimensional gives us headache. Okay, but we can define those matrices, n-dimensional matrices, and then define some operation. We can all program this in computer science. Okay, we can program all these different number system, and that's the power of computer science, the computer programming. Okay, no matter what it is, we just program once, then it does the rest by the power of computer programming, computer CPU power. Okay. Yeah. So computer. So anyway, we talked about Einstein and Thomas Edison. Okay, this is hardware and software. All right. So Einstein, yeah, he does all these theories, or physicists like Maxwell or Röntgen, or whatever. All these famous like Newton or Galileo Galilei, all these physicists. Okay, they do all the theoretical. That's more like software stuff. But they're hardware guys who are inventors. They actually make machines, light bulbs, like Thomas Edison or Tesla. Okay. So software and hardware, they kind of work together. Okay. So like electricians, like inventors, they work with the hardwares, right? But software engineers, computer programmers, they're like kind of like physicists. Okay. They do theoretical work. There is computer science, which is our software, and there are computer engineers, which are like like hardware guys. Okay. So yeah, they should work together, more like metaphysical and physical world. Okay. So okay, enough of the preliminaries. Let's take a break, and we're gonna get to the top of this, the goal, not the bottom. We covered enough bottom part. We'll do more eventual goal, humanology stuff like religion. Okay, we talked somewhat politics a little bit, but yeah, we'll go to the group of a person, personal group. Okay, before that we take a break. We'll take a break and we'll get back. Okay, we're back. I'm sorry if I sound a little bit harsh and rude today. You know, I mean, my day was fine today. Okay, I had a fine day. It's just that we have so much to cover. Okay, I'm under pressure. Although this is all kind of my favorite hobby, you know. Yeah, still we have to hurry up. Who knows what's gonna happen tomorrow? We gotta do our best, right? Our very very best to advance human knowledge, humanology. Okay. So you have to forgive me, okay? And thank you for that. And I'm getting hungry too. All right. So okay. So yeah, this recursive structure is everywhere in nature. Okay, because look at a tree. You have this branch, tree branch, right? And each of this, okay, there's this seedling, right? You have this germination from this seed, just like Jesus said. You have ground, the seed goes under the ground, then it makes this, what do you call this? Sapling, whatever, right? And then it branches out, right? And then it grows up, and then each branch out again, and each branch out again. And that's actually how a snowflake grows. If you actually motion picture it, the growth of this water, you freeze the water, right? Water drop, then it goes like this. That's snowflake, right? Okay, so that's why you call this Koch triangle as a Koch. Nickname is Koch snowflake. Okay, so this concept of recursion, it recurs. Okay, so Friedrich Nietzsche, the German. I know a little bit of German. All right, German philosopher. He talked about eternal recurrence. Okay, so it's like circle. It repeats itself. All right, so recursion is something very natural. It's not just mathematical. No, it's something very natural. Mathematics is a model of nature. Okay, so and this has to do with exponential function, like y equal 2 to the x. Why? Because here, this is more like y equals 3 to the x. Okay, so but we had this application in politics, right? One nation divided into two states, and each state divided into two counties, and each county divided into two towns. Okay, so first there was one, and then it becomes two, then it becomes four, and then it becomes eight. 1, 2, 3, 4, 5, 6, 7, 8 is equal to 2 to the third. Okay, so each time you multiply 2, 2, 2, 2, right? And in mathematical notation, we call it pi. I is equal to 1 to n. Well, pi in capital letter, Greek capital letter pi, equal I is equal to 1 times 2 times blah 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 times n is equal to n factorial. Okay, now pi I is equal to 1 to n of 2 is equal to 2n. Why? Because you're multiplying 2 times blah 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 n times equal to, no, 2 to the nth, sorry, 2 to the nth, 2 to the nth, okay. Now sigma, we are by now you're familiar with this, okay. Sigma I is equal to 1 to the n of 3 is what? 3 plus blah blah blah, you do it n times, okay. This is 3n, okay, 3 times n. Now sigma of I is equal 1 to n of I. This is n plus 1 over 2, which is 1 plus blah blah plus n, okay. All right, so that's sigma pi notation, okay. So this is like exponential kind of thing, okay. This recursion, okay, it's more exponential growth. And this is the kind of the, Malthus, economist Malthus, Malthus. He's a good economist, okay. So his theory is proven to be false, but at the same time he is a good economist, and he gave us valuable insight and application, and it's a good concept, although it's proven to be wrong, but still it has some very good theoretical contribution to our understanding of human world, okay, because many things in human world are exponential. The spread of information, for example, like we use the term, oh, it goes viral, right? It has to do with biology and sociology as well. Okay, the spread of information. How can information just propagate in human society so fast? Because exponential growth, just like the spread of a disease. So Malthus, his idea was population growth, okay. So it's a good theory but a wrong application, okay. But many of the core idea of his theory is valid, it's a very valid one. Malthus's contribution in humanology is that there are a lot of exponential things in human world, like the propagation of a disease, or propagation of information, propagation of this concept. As a good concept, evil concept, good ideology, evil ideology. Just look how fast gayism, pro-gayism, dominated this entire Western hemisphere. It happened over a decade. Now entire Western hemisphere is conquered by pro-gayism, LGBT activism, gay marriage, or marijuana, tattoo piercism. It spreads so fast. Why? Because it's exponential growth. Exponential function is this. So you have y equal x, this linear, and y equal x squared. Parabola. This is y is equal to x, linear function. Y equal x squared, parabolic function. Then you have this exponential function that goes like this. It's even faster. Y equal 2 to the x. Exponential function is very fast. It grows very fast. Why? Because spread of information or spread of STD, like AIDS or herpes, or spread of information or spread of ideologies like this. First, there was one person, okay? One person, let's talk about AIDS. One person, you're male gay, so you're promiscuous, you're sexually aggressive gender, unlike female gender, who is uh, sexually passive. Women don't want to have sex maybe once a month between the age of 20 to 50. Yeah, they want to have sex once a month. But males, they want to have sex every day. Okay, and they want variety. So male gay, that's why male gays tend to get a lot of STDs because they get to they have sex with multiple male partners. Okay, okay. So STD in male gay population is like spread like fire, wildfire, dry forest. Okay, so one male gay have sex with two men, and each of these two men have sex with two men. Okay, and each of these four men have sex with two men, two other men. So it's a one becomes two, becomes four, becomes eight. It's exponential growth. Okay, that's spread of any disease. It's not just STD. Any disease, any disease is STD. Anyway, you catch a cold. You come in contact with two people, and so they get cold virus. Each of these two people come in contact with two people. Now four of them is infected. Okay, not just that. It's actually summation of that. One plus two plus four plus 8. Okay, so I forgot the formula for that. Okay, you can look it up. All right, like sigma 2 to the n. Okay, let's derive this real quick because it's not that hard. I remember I learned this in high school in Korea. So let's say 1 plus 2 plus blah blah plus 2 to the n, this Sn, right? Now, Sn plus 1 is equal to uh, 1 plus 2 plus plus 2 to the n plus 2 to the n plus 1, right? Now, and 2 times Sn is equal to 2 plus 2 to the second plus 2 to the n plus 1, right? Which is same as this. So S n plus 1 is equal to 1 plus 2 times s to the n. Okay. Which is equal to 2 to the nth. I mean 2 times Sn. Sn plus 1 plus 1 plus n is no, wait, not this. 1 plus 2 is the same as n plus 1. Oh boy. I'm sorry, I'm kind of blanking here. When we calculate this, like AN is equal to, and I mean ASN is equal to 1 plus N, and then SN plus 1, we calculate, okay, I'm kind of getting it now, kind of getting it now. Which is called N plus 1, then we have 2Sn is equal to N plus 1 times 2. No, how do you derive that? 2Sn equal 1 plus N. Oh, just times N. Okay, so we never introduce Sn plus 1. Okay, I got it. So we added them up. Okay, so we added them up. Sn. Now we subtract. Oh, now I got it. Now I got it. I know. So this is 2 times Sn. This is Sn. Okay, so we subtracted. Then we subtracted. Then Sn is equal to. You subtract upstairs from downstairs. Okay, then this guy all cancels out. All right, this cancels out. This cancels out. So 2 today, N plus 1 minus 1, okay, over 2 minus 1, because 2 is just one number, right? And to generalize, we use R as a rate of growth. Okay, so Sn in general is like R minus 1, then you have R n plus 1 minus 1. Yeah, that's the general formula for the y equal R to the x. Okay, so when it's 2 is a special case, then it's that. Okay, so the bottom line is, it's an exponential function. Okay, so you add them all up, it's still exponential, because this guy is a constant, n is the variable. So yeah, you sum them up, it's still exponential function. Okay, so exponential growth, there's growth of the disease. All right, it's still exponential, and it doesn't have to be something bad that spreads. Okay, it could be something like Holy Spirit or knowledge. Okay, music, some painting, something good, or some brand new product, right? iPhone or Microsoft operating system, or whatever, brand new product, brand new idea, or some actor, some movie. Yeah, it spreads in the society like exponential, because one person, it's like a grassroots, or something that go viral. One person spread to 3 of his friends, and each of those friends spread to 3 of their irrespective friends. Okay. So it's kind of a simplified model. It's not exactly that, but because they are mutual friends, right? But yeah, things can spread very quickly, and nowadays it's not just words of mouth. It's there are online media like social media like Facebook and Twitter, YouTube. They are all fantastic companies. They are American inventions. Okay, social media. In California, San Francisco, Silicon Valley. Okay, a YouTube video that goes viral. So that's why evolution of data, information in this day and era can happen very fast. Okay, uh, so evolution of an ideology can spread very fast. Because nowadays everybody has cell phone. Okay, Twitter, Facebook, YouTube, Google, Bing, online media. So it is possible that I become the president in 2020 in America, United States. Okay, because what I do, yeah, is online, so it can spread very fast. So yeah, I still have some high hopes that me becoming president. Whatever. Okay, now we are digressing again, and enough of this. Okay, so now let's go to our goal today. They are all preliminaries or some tangentially related subjects. But our main goal, main agenda here, or agendum, because we're going to talk about just one single goal topic. In the end, we did all this to do this to talk about this one topic, our goal, objective. We had single objective here. Okay, it's about person group. So you may not be a celebrity, but many people know you. Okay, so you are the center of your own universe. Like egocentric. You being egocentric is something natural. It's not just human being. You have a dog. To your dog or cat, that dog is the center of the universe. Okay, you are nothing but a planet. That dog of yours is the center of the universe, right? Egocentrism, because in the universe, every single point in the universe is the center of the universe, but at the same time, there is no such thing as center of the universe. Okay, because space is infinite, right? So yeah, everybody is center of the universe, but at the same time, nobody is center of the universe. Center of the universe. Okay, man, I have thick accent. If I speak fast, I don't think anybody can understand it, right? So person group. Okay, you have, let's say your name is John Doe. Okay, you're Doe, Mr. Doe. Doeism. Deism. Doeism. Okay, so there are people who like you. In the universe, in your universe, of course, there are three groups, right? This is your universe, okay? Universal set. And there are three groups. There's your name is, you are Mr. Doe, anti-Doe, and neutral Doe, and pro Doe. Okay, the people who are your enemies and people who don't know you, who kind of know you, but who are your acquaintance. They are neither your friend or your foes, and there are people who are your friends. Okay. Now, disregard this. Let's just think only about your pro you people, your families and your friends, people who love you. Okay. There are two components. Okay, we talked about this before. Okay, so effect or force. Let's just be consistent. And effect is equal to this person's power times this person's view. Okay, so you have somebody who likes you. And this person has huge power, but he likes you a little bit. He's not your friend, but not a very close friend, kind of remote friend, but he happened to be a very powerful person. Okay, maybe he's a chairman of some organization, or he likes you a little bit. Okay, but he's a very powerful person. Then there can be some person, your very close friend, who's a huge positive opinion about you, but he's nobody. Okay, he's just like you. He's just salary man making average American salary level, just like me. I'm a very close friend of you. Sorry for the sputtering, but I cannot clean that up because if I touch the screen, my laptop is touch screen, so you will stop the recording. Okay, sorry, but you don't get to see that sputter on the screen anyway. So I cleaned that all later. Okay, so me, I'm your very close friend, but I'm nobody. So I don't contribute to your power very much. Okay, so well, first of all, power of you. Let's say you have no enemies. If you have enemy, yeah, you can put negative term, but let's simplify. You only have friends. Okay, so it's power of you. You is a sigma part of individuals that belong to your group, your friend group. Power of this person times view of this person on you. Okay? That's the power of you group. Power of your group. Okay? You kind of got the point, right? Let's say there is this big person, very famous person. So this is you, your group, okay? Group you, your fan group, okay? And there's this very powerful person, and he loves you very much. Okay, he's huge fan of you, and he happens to be like big time CEO or big time politician, like governor or president even. And he happened to be a very close friend of yours. Maybe your high school buddies, okay? Or if you're a woman, okay? Then this person, very powerful person, maybe your husband. So you're what, first lady, right? Okay, something like that, or yeah, that kind of stuff. You got the idea. And then there is this very small person. Okay, you are a person, right? Then there is me. I like you a little bit, and I'm nobody. So I'm your small friend. Okay, I like you just a little bit, but also at the same time, I'm nobody. I'm not nobody famous. Okay. All right, and then we talked about this before, but we briefly just summarize it. But let's say you're a singer, okay? You're a country singer, some celebrity, okay? I like some country music, okay? Like Dix Chicks or okay, let's talk about Dix Chicks or Sheryl Crow. I like so, I don't like Sheryl Crow very much because I think she's stupid, just dumb blonde. But I like some of her songs. Maybe actually I like two of her songs. What's that? Every Day's Winding Road and Suck Out the Sun. That's about it. Okay, other than those two songs, I think she's just dumb blonde. Oh, Dixie Chicks. Okay, I like two of her songs. Okay, so do I think they are dumb blondes? Maybe a little bit. They talk shit about George W. Bush Jr. and then all their recording career kind of tanked, right? I mean, George W. Bush, I'm not a huge fan of him, but I kind of like him, okay? So, yeah, so Dix Chicks, two songs I like, I'm ready to run, and I can love you better. Yeah, I wanna use all those four songs by these dumb blondes as my campaign songs. Okay, they may hate it, right? Depends on how much they like me or hate me, right? So let's say there's this fan group of these chicks, okay, and me, I happen to be notorious guy in the future. Right now, I'm neither notorious nor famous. I'm neither famous nor infamous because I'm nobody. Nobody knows me. But later in the future, I may gain as a popularity, like huge popularity. I may be regarded as the second coming of Jesus or second coming of Hitler, Antichrist, 666. Who knows, right? But I'm neither. I'm just a human being. I'm just an Asian guy in Alaska. I'm neither Hitler nor Jesus. No, I'm just a guy. Okay, who exercised the freedom of speech in America. Okay, but I may gain some notoriety or some positive fame. I can imagine those things, right? It'd be nice. They'd be interesting. With popular or notorious. Yeah, you make my life interesting. I don't care, okay? It may happen after I'm dead too. I don't know. Whatever. Okay? I do what I can to I do what I can to better the humanity in the way that I believe. Okay? I work for justice and righteous according to my opinion. I may be wrong. I don't exclude that possibility. I may be all mistaken. All this could be my mistake or my ignorance or my stupidity. I admit that possibility, but as far as I believe, this is the right thing to do. Okay, so I do my best, right, to the best of my knowledge. So I do what I believe is the best for humanity. That's what I'm doing. What I'm doing. Okay, so yeah. Let's say you are some celebrity, country singer, and I'm your huge fan, right? But I'm notorious. People hate me. That's what happened to the Beatles. Helter Skelter. What there's this Californian kind of criminal group, Manson family, something like that, right? They were huge fan of the Beach Boys too. They kind of hung out with the Beach Boys to some period of time, I guess. And then they killed many people. Charlie Manson family, and whatnot, in California too. And they're also a huge fan of the Beatles. So Helter Skelter, they killed some people and wrote down Helter Skelter in blood, I think, on the wall, something like that, right? So yeah, it kind of damages the Beatles a little bit, right? Because they're a huge fan of the Beatles, the Beach Boys, right? But people hate them. So they have some negative impact on the reputation of the Beatles or the Beach Boys because people start to speculate like, did the Beatles or the Beach Boys kind of inspire them to commit those murders, serial murders? So are Beatles and Beach Boys somehow, are they to deserve some blame for all those heinous crimes that this Manson family committed? Okay, so they have some negative impact. And so how does this equation capture the phenomenon? Power can be negative. Okay, so you have sigma, your summation, you have this negative power, and how much they love the Beatles. Okay, so it's multiplication of this negative power times positive view of the Beatles. So now in sum you have some negative effect on the power of the Beatles reputation, all right? But they're fairly small group, so no matter how much they love Beatles, huge fan of Beatles, fairly minor impact on the overall reputation of the Beatles. Okay. Now, okay, let's talk about the Beatles. Okay, so let's say there's this huge positive figure that love Beatles, so it enhances the power reputation of the Beatles quite a bit. Who is this person? Let's say for some contemporaries of the Beatles, 60s. I don't know. Okay, Elvis kind of president. I mean, precedent of Beatles. So let's say Rolling Stones. Okay, Rolling Stones. Yeah, they endorsed the Beatles, so it boosted up the popularity of the Beatles. Okay, and it's kind of fictional, right? So why is does that matter a lot? Because Rolling Stones, they themselves have a lot of fans, the fans of Rolling Stones. So at the moment that Rolling Stones endorses the Beatles, all these fans that belong to this Rolling Stones group, they become a fan of the Beatles too. Again, I'm simplifying. Okay, I'm not saying this is the way it is, reality. I'm just simplifying. Okay, so or you have this big politician like say Donald J. Trump, and he got some big endorsement from Police Officers Association, big labor union. Okay, it boost up his popularity, Donald J. Trump popularity a lot. Why? Because this police group, it itself have a lot of members. Okay, so you used to have this small group, okay, and then you say the Donald J. Trump, okay, then you have this police group, which is fairly big but not as big. And police group, yeah, they tend to have positive reputation, right? Now you have it become this bigger, okay, this D plus P. Donald J. Trump endorsed by this police group. Okay? So that's the concept of recursion. You have this group, and you have inside of group you have a subgroup, and inside of the subgroup you have another subgroup, and another subgroup. Is it repeating itself? It's a recursion, recursive group theory. Okay, and also it's dynamic too. So dynamic recursive group theory. Okay, or dynamic recursive set theory. Okay, because we are not, yeah, in humanology group is set plus rules operation. Okay, so yeah, it's pretty much equivalent. Okay, so that's why we talked about this recursion in mathematics and computer science. And as you can see, details doesn't really matter. You don't have to know what computer scientific recursion function is. You don't have to. There's this. Not every computer programming languages support this recursive function. There are some old computer programming languages like Fortran or C that doesn't really support this recursive function. Nowadays, mostly they do. They like Python, whatnot, and recursive function theory. There is this huge area in theoretical computer science, like I think it's like lambda function or gamma function, whatnot, right? Beautiful mathematical abstraction, in a computer programming language theory. Okay, but you don't know all that details, okay? Because I told you, you don't have to know all those fancy mathematics, computer science. I mean, the kind of things that we do here isn't that fancy. It's fairly elementary, college undergrad level, right? You don't even need to know those things to be a good humanologist. but the principle of recursion is pretty much the same. Okay, you have this snail that kind of spirals down, right? Or tornado or hurricane, right? Something very recursive. Okay, so and you have this fern or tree leaves. You have this fern, it's like this and then like this. Okay, it's this concept of recursion. Okay, and you have these parents. Okay, great grandparents and then become grandparents and then your parents and oh, there's you and you have children, your grandchildren, great grandchildren. Okay, so it's exponential growth and recursion. Okay, that's why we talked in length about this recursion. Okay, because something very ubiquitous, universal in nature and in human world, society. Okay, so let's call it a day. Okay, because I need to eat. All right. Okay. Good night. Thank you. Thank you for your being patient and tolerant. Thank you for being so kind. Thank you. Bye.